So, good morning, everybody. Greetings from Finland. My name is Mari Lundström. I am professor in hydrometallurgy in Aalto University, Espoo. I'm also PI of Finland-based battery metals ecosystem BAT Circle and chair of Batteries Europe Working Group 2 Raw Materials and Recycling. And today we are here with highly important topics. We address the questions of realistic limits of battery recycling from industrial point of view, but also from the regulation point of view. As we all know, lithium batteries recycling is not equally easy compared to, for example, lead acid battery recycling. Such a complex product was never made for recycling. It was never designed for recycling. And even 100% recycling is not environmentally always the best option. So where should we target and how can we achieve that? Today, Claude Chanchon, Secretary General Recharge, will talk about battery regulation and state of play and implementation challenges related. We also address questions related to battery material flows. It was recently predicted by Hans-Erik Melin in IPMS conference that batteries reach their end of life slower than we have expected. So maturity only after 15 or 20 years, and remanufacturing, repurposing, reuse are evident part of the battery lifetime. It has been predicted that 2030 we have only 5, maximum 10% of raw material that comes from the battery recycling. So it's evident that primary production will dominate the raw material feed, and presentation of Kristen Hagelukken Umicore will address the theme of tracking and tracing of battery material flows, the case of battery passport. EU is also highly dependent on primary battery raw materials, and the ownership of batteries that are currently in use are dominantly by the customers, by the end users. So it's clear that there is need for value chain partnerships in battery recycling, but also in primary production. And Christophe Quinault Solvay will discuss this topic. So now it's my privilege to let the first speaker take the stage. Claude Chanchon, please, stage is yours.
Thank you very much, Mary, for the kind introduction. I'm Claude Chanchon. I'm the General Manager for Recharge, this Advanced Rechargeable and Lithium Batteries Association in Brussels. Next, please. Indeed, my topic is about this creation of the new European battery value chain, the regulatory challenges and issues we may see with implementation. Next, please. First of all, a few words on Recharge. We represent the full battery value chain from raw materials to recyclers, including, of course, battery manufacturers and companies placing the batteries on the market like OEMs. And of course, our point of view on this new regulation includes or covers all of this full value chain approach. Next, please. We have seen this new regulation, of course, as expected, as this milestone in the Commission proposal and action to support this European Battery Alliance. Everybody heard about that, which was this political move to make a vision or support a vision for sustainable, innovative, and competitive batteries made in Europe. And this is very much supported by our own industry approach. First point, there is about competitiveness potential for European battery here in the new regulation. We expect this new regulation to help making a lean and coherent regulation. And as I said, we support this full value chain approach. Next, please. So when it's come to the content, those of you who have read the batteries regulation proposal of the Commission recognize, excuse me, it is quite complex. We have classified a number of points on the left side here, where we very welcome the new regulation because it's, from our point of view, driving in the right direction the industry. We mentioned about coherence, the will to be create legal certainty and predictability for supporting the strengthening of European battery production and deployment. And the point 5 on the left side is important for us because these are really some key criteria we very much support to provide with new sustainability measurements for the battery's performance, carbon footprint, due diligence, battery passport, and so on. But on the right side, you see there are a number of potential risks we see in this proposal of regulation. And here you can see a significant list of potential risks attached with the implementation of the proposed regulation. I will not come in details, but I would like to underline some specific one. So next, please. Because in fact, our global approach is to look at this regulation and answering the question, what do we need to make this circular economy approach happening in Europe? First of all, it's important that the regulation is setting level playing field or equivalent conditions. And we have found in the regulations at some points certainly need to be clarified or supported. This is the first risk we have identified. The second one is we agree and there is a need to have these new criteria for sustainability that support the economic development when the circular economy is not economically valuable by itself. And so carbon footprint and due diligence, we certainly welcome that new criteria that may become part of the competitive offer. That's really a second important point. And the last one is finally make the regulation as flexible and driving in the right way, but without imposing measures with lack of benefit for the environment. And we have seen, for example, that there is in the proposal this recycled content proposal, which, by the way, is proposed to become mandatory 10 years from now. So our point is it's too early to discuss of this now, as, by the way, more or less accepted or proposed by the Commission, as the targets are set for the after 10 years from now in 2030. So we believe it's probably not necessary to increase complexity as of today on this type of targets. And the second last point here is about the recovery operation, recycling, which of course have to be ambitious, but also carefully balanced, not to be excessive. And I would like to underline a little bit what we mean with excessive ambition in recovery targets. Next, please. There are studies here, like on this example, which were published beginning of January of this year, so quite recent, to assess what type of benefit can we expect, or what is the economically feasibility of recycling in Europe. And as you can see here, you see the profit is negative. You have a red box here which shows that in Europe today, you need to have support of the producer to have the recycling of lithium batteries in this diagram, which is presented here. Next, please. But when we compare this diagram to China, you can see that the square on the right side, which is representing the profit, here is becoming positive. And this is the case which is expected for Europe after 2025. And indeed, this would, in fact, very much help the circular economy, because that means that all the economy stages from raw material until recycling would be driven by economy and then become competitive markets. So we believe that's really a good target, and then, of course, a purpose for the regulation to support this ambition. Next, please. The issue we face now is that, we talk about recycling. In fact, we talk about many things. I presented here intently, several diagrams presented by various recyclers. And my point is not here to compare or to criticize, because everything may be possible and some of them may be profitable or non-profitable. But what is for sure is that when you talk about recycling, you can start from some, let's say, quite straightforward cycles, like on the left side, to much more complicated processes, like on the right side example, for recovering materials. And in general, my comment is that, of course, the more complete the process or the more complex, and the more opportunities you have to recover more materials. And indeed, this is driving my comment for the next slide, please. In this slide, what we consider is that today, the basic assumptions in the Nomura Research Institute, you just have seen, was something which was represented on the left side, where you have a cost for the processes which is corresponding to existing processes. The point I want to highlight here is that if we increase the target for recovery, we may need to add multiple processes or more recovery processes in order to achieve, these targets we have seen, like 98% or 99% of recovery rates. And as a result, of course, more processes needs more cost, and it would be easy, as you can see, to move from the left side position here of prediction of 2028 costs that have a positive profit orange on the top, to move to the right side, where again a negative profit, which is a loss due to not so much, but already, let's say, very possible increase in cost due to more requirement in processes for recovery of, let's say, excessive or too ambitious recovery rates. So that's an example about cost. Next, please. Here, in fact, what I wanted to compare again is that compare the vision of the 2028 recovery cost and the competitiveness of the European industry compared to the Chinese industry on the right side. As you can see, today already in 2020, the Research Institute Nomura announced that the recyclers in China are doing benefit, and therefore they could become, due to excessive ambitions, competitive and more competitive than European manufacturers on the long term. So that's one risk I wanted to underline based on cost. Next, please. The other risk is about environment. And again, adding additional steps for recycling has also consequences on the need of more material, more solvents, or more energy to have more processes running and recover more material. And I've made a rough assessment on the graph here, you can see on the right side. What you can read is that you have the carbon footprint of the battery, which is 100% as produced. And if you recycle and recover materials, then you see the battery carbon footprint will be reduced because recycling processes have less cost than primary processes mining. So that's the benefit of recycling. But if you add more and more recycling processes, then of course the impact of recovery process will increase again, and it's quite easy to find again when you go to 98% that, well, the carbon footprint of the battery will in fact not be improved or even slightly degraded by the recycling process. And this would be in fact at the benefit of a little bit more material recovery, but at the expense of the carbon footprint. So that's again, I wanted to underline what we call an unbalanced approach for the recovery targets. Next slide, please. And that will be, in fact, come to my general conclusion. The general point is higher is not always the better when it comes to recovery rates, for example. And also we have to be careful when we talk to targets or hard fixed targets like proposed in the regulation, to have differentiation, for example, between technologies, which is the second point here. We all know that iron phosphate batteries, for example, may not have the same content as others, and then they have to be considered when it's come to recovery rates. And also here, the minimum performance for all products may hinder the development and the potentially also development of new technologies for recycling also, if they don't reach all these very high targets as explained. Next, please. So coming back to the regulation, yes, we have a regulation that could very much help the battery industry. We did underline this. We have everything here in place. We have a local market growth, which is the first part. We have a potentially new way of competition. So adding environmental and social impact criteria may help the Europe to compete. So that's a very positive second point. And then we have a regulation that may help also having a level playing field. But there is a but. Next slide, please. There is indeed the risk that excessive ambition, for example, reduce the feasibility and the benefit, as we just have seen, either the benefit on cost or the benefit as well on environment. And this would be counterproductive. And as well, of course, we need to make sure that this enforcement is really as efficient as expected. Next, please. And that will be my conclusion. And I would say thank you for your attention. There is a lot of room for research and development on the recycling aspect as well to make this circular economy becoming more competitive, because that will be the game of the future years. Thank you.
Thank you, Claude Chanson, of very realistic and inspiring presentation. So I'm sure it will raise questions, and in case you want to make questions, so those will be possible in the end of the session. Some of the questions will be picked up for discussion if there is chance, but you can put questions for chat, and there will be moderator handling those ones. But we will go further, and next presentation will be by Christian Hagelucken from Umicore. So please, Christian, stage is yours.
Yeah, thanks a lot, Mari. And so my presentation is on tracking and tracing battery material flows, the case of the battery passport, and I will highlight a little bit in the next slides what we mean with this. Can I have the next slide, please? Okay. So Claude already mentioned the new battery regulation. I only can echo it's really a milestone. And the big advantage of the new regulation is it's not anymore a waste directive as it was in the past. It's really a resource regulation. So it's really focusing on the complete life cycle and on circular batteries. And I use here one graphic which often has been used by the Commission when explaining on the legislation, and it has the different paragraphs, key paragraphs in the regulation, and as you see in the center, there is mentioned about the battery passport as well. Can I have the next slide, please? So what I did here is I regrouped a little bit key requirements from the regulation, which are linked to data availability and traceability. And as you can see from our point of view, the battery passport is pretty much in the center, and it will be a key enabler to achieve a number of these requirements. And if we start from the left-hand side, so it's about assessment of hazardous substances. Here, the battery passport will have information. It's about mandatory CO2 footprint. This already was mentioned also by about minimum quotas of recycled materials, so the recycled content. Then the requirements about responsible sourcing. So, for example, mandatory human rights due diligence, full collection of batteries and recycling efficiency. Here I want to add to what Claude said. What is extremely important if you talk about recycling targets, that we have very clear definitions. So where does recycling start and where does it end, and what is required at the moment is a bit unsharp in the draft regulation. There are requirements for support of second life applications and also on green public procurement. For all these requirements, a battery passport can help. And what we also need to understand that not in all cases, but in most cases, we will have data flows in two directions. So from the one side, from stakeholders into the passport, but also from the passport to stakeholders. And later on, I will explain with you what I mean with this. Can I have the next slide, please? So when I say we, on the one side, we is Umicore, but Umicore is also a member of the Global Battery Alliance, together with many OEMs and many other key stakeholders in the battery value chain. And from our point of view, the battery passport has three main functions, which are all meant to support a sustainable and circular business environment. First, transparency. It's about creating transparency to all relevant stakeholders on practices and impact along the battery value chain. And you could say a little bit, this is from responsible sourcing to responsible recycling. So really covering the full life cycle. Secondly, and this is very important, is on benchmarking and standard setting. So we need the passport also as a framework for benchmarking of single batteries along ESG criteria, and also providing minimum acceptable standards for sustainable and responsible battery. By the way, also standards for sustainable recycling of batteries. There was, I already saw a question in the chat that maybe in China there are less requirements on social performance or environmental performance. And indeed, we have to make sure that we create level playing field here for recyclers by having standards. And the last part is, the last function is on progress, tracking and validation towards achieving a pathway for a sustainable and responsible battery. Can I have the next slide, please? This graphic has been developed in the Circular Economy Initiative Germany, and within this initiative there had been a working group on traction batteries, which I had been chairing together with Arno Quade from Braunschweig University. And what you see here is the principle, a little bit the concept of data flows. And as you can see, we really need data flows on the entire value chain. So it starts with raw material extraction, you have refining, you have production of precursors, cell production, module, and then distribution of the battery into the market, the use phase, collection and return, and in the end also recycling and recovery. And the digital passport, the battery passport is meant as a digital twin concept, which reaches far beyond the battery itself. There are some data which start to be collected even before the real battery exists. Think about data on mining and so on. So this passport also needs to have interfaces with existing, for example, responsible sourcing tools. Of course, it must be interoperable with this kind of traceability tools. Can I have the next slide, please? To better understand a little bit what is the concept of a battery passport, it can be helpful to compare a little bit the battery passport with a personal passport all of us have. If you take a personal passport, this personal passport has on the one side information on the identity of the holder, so a place of birth, location of birth, body height, eye color, and so on. But you also need your personal transport when you are traveling. And traveling means if you are crossing a border outside Schengen, you have to show your passport, then you are registered and deregistered country again. For certain areas, you even have to apply for a visa to prove that you are traveling with good intent. And one day, when we die, our pilot passport will become invalid, and we will be deregistered from the system. And a little bit following this analogy, this logic, also the battery passport has to function in a similar way. So it will comprise on the one side static data. These are data which are embedded in the battery when it is put on the market. And I listed here some examples. So it's information about supply and production chain, material composition, verification of responsible sourcing of raw materials, information on the CO2 footprint, on recycled content, for example. It can include a dismantling manual and things like this. And these kind of data are accessible to defined authorized stakeholders. But on the other side, and this is very important, that of course we also need to have in the passport dynamic data, which in the use of the battery and also at end of life. And these dynamic data, they include information on the use phase, including a potential second life if it takes place, on loading cycles, on state of health, on crossing system boundaries. For example, if an electric vehicle or battery would be leaving Europe, then this needs to be, like with a personal passport, it needs to be notified in the system. The fate of at end of life, the verification that at end of life there really is a sound end of life management, so responsible recycling, which is as important as responsible sourcing, achieved physical recycling rate, and so on. And these data need to be communicated between the passport and an overarching battery platform. And of course, there also need to be verification tools which ensure that it's real data, it's realistic data. Can I have the last slide, please? So summing up, from our point of view, the battery passport will be a key tool for a sustainable, responsible, and circular battery. The battery passport as a digital twin of a physical battery will become the key transparency, tracking, and tracing tool. It's needed to report ESG performance by standardized key, and it's also needed to secure a comprehensively closed battery loop. It will become instrumental to fulfill the requirements of the new battery regulation. There are several activities underway within the EU to develop the concrete standards and procedures for the battery passport and to demonstrate these. So the concept is there, but of course you have to fill this with content and also with technical standards and interoperability interfaces and so on. The Global Battery Alliance unites stakeholders working for a sustainable and circular responsible battery ecosystem. And Umico as a company is very actively involved in various projects to develop and advocate for the passport. And with this, I come, I think, to my last slide. Can you please click, which simply says thank you, and I'm looking forward to the discussions and your questions. Thanks.
Thank you, Christian Hage-Lykken, for very informative presentation and a bit helping us to understand how we could be more transparent and open with also our raw materials, whether it is primary or secondary sources. So actually also related to a bit to the same topic, but we continue with the partnerships. So battery recycling, the need for value chain partnerships, and Christophe Quinault from Solvay will continue with his presentation about this topic. So please, Christophe, stage is yours.
Yes, thank you very much. So very glad to be part of this session. So it's really, as you mentioned, the continuity of the two former presentations where Claude frame what will be the regulation frame on the various challenges we have, and we have the passport, which is really an enabler to make this value chain of recycling made available in Europe. And I'm going to make a presentation to show how a company like Solvay try to make it happen as part of the value chain of the recycling. Next slide, please. So first, what is Solvay? Solvay, we are a chemical group. So we provide some chemical solutions in order to always enhance the various process. One of the key topics of Solvay today is that there has been a clear focus on whatever is sustainable solution. So this is really the driver of the chemistry that we are today developing in Solvay. You can see what we are going to bring here is a global vision. So I have seen a couple of questions about what is the situation in China and US, and I will be pleased to answer these questions. Next slide, please. So today we are talking about circular economy, and this is the goals, what we call the Solvay One Planet goals. And circular economy is definitely one of the topics. Today we are devoting 5% of our turnover to these, to only circular business models. And the objective is to double it. And obviously, the recycling of batteries is part of it if we believe we can bring something. The second part, which is really focusing our effort, is the CO2 reductions, obviously, and massively the waste reductions. And for instance, Solvay is part of the battery value chain. We provide some chemicals there, but the increase of demand will come with some investment, which also focus on the fact that there will be less waste for more productions. Next slide, please. So if we go to the circular economy, how does it work? And this is more a frame. It's not only valid in Solvay, but we come to touch what is the need of partnerships. When we talk about circular is in opposition of linear. I'm buying to somebody, I do something, I sell to somebody else. And I don't really care of where it's coming from. I don't really care where it's going to be out. And with the circular economy, we take care of everything, of each steps, and we pay attention to the fact that globally, as a part of the value chain, we pay attention to bring an added value there. Subjectively, the first thing is to look after the circular sourcing. So how can I make this product on this sourcing renewable? Can I find it from a recycled source? This is typically the kind of questions that we first ask. Second part is that, are we part of this value chain of circular economy? Otherwise, you can easily go down to what we call the greenwashing. So first of all, do you really bring something to this value chain? If you do, then of course, you are a big part of this value chain and you have to discuss with the others. And then once we are there, as a chemical company, we have to think about it by saying, can we provide a process? Can we provide a chemical? Can we provide a product for anybody else, which could enhance, share, or bring some added value to the other partner of the value chain in order to bring the step which is mixing in this circular economy. And obviously, you can see it cannot work without partnerships. So networking or not working, this is really our motto. I mean, it's really something on which we have to make it happen. We have to deal with some others and to trust each other. Next slide, please. So if I take the example of the battery is made of many products, and which is raising, of course, a lot of problems. We have mentioned the safety, the duration, the performance, the lifetime, and whatever. So we're involved in various of these things. What I wanted to focus here is something which is quite easy to figure out. The battery is made of a lot of metals. For everybody, it's quite clear, and it's pretty clear that this metal can be recovered. We have the example of aluminium, copper, but the metals in battery is a bit more tricky, and Claude Chanson mentioned it. We have to pay attention to the fact that what is capable today and what we are capable for tomorrow. Today, in the fields of metal recovery, Solvay, we are a big actor of the mining industry. So we help the miners to be able to extract some ores, the metals which have some value for them, which are able to be sorted out easily. So these fine chemicals, we are working at the atom levels, is helping them to sort them out and to have a great performance at the refining stage. So obviously, when we look after it, we have some quite leading positions and very innovative solutions for nickel, cobalt, manganese, and lithium. And guess what? It's one of the major components of the today batteries used in the car industry. What we are going to look after there is to say what is valid for the ore industry is certainly valid for what we call the urban mines. And any battery contains about 6 times to 7 times more metals than the ores. So we were looking after how we can apply these in order to reduce the impact on the footprint. The more metals you can recover for the battery is less metals that you have to dig further in the mining. And the second part is how you can also reduce the CO2 footprint. If you can extract from a urban mine 6 times more ore than a primary mine, obviously you have less CO2 footprint. And if you can make it locally, so Europe in Europe, China in China, US in US, or whatsoever, then you also save the transportation of massive amount of value. Next slide, please. So this is what we are going to do. And as I mentioned, it will not come. It will not come from a laboratory bench alone in the dark. So for this, we partner with 2 famous companies. So one is Veolia, because Veolia, as part of the recycling, you have to collect, sort, discharge, grind, and sort out what we call the black mass, so the first level of waste of the battery, before we are able to enhance all these metals. So Veolia is bringing to a certain purification stage, which is already a recycling stage, but what we call a downscaling. That means that the metals are used most of the times in the siderurgical industry. So what Solvay can bring here with our additive is to be able to purify them to the level of the battery grade in order to create a circular economy. And for this industry, it's massive. Today, we are going to multiply by 10 the number of cars in the market of Europe. It's going to be the same for the battery makers. We are going to multiply by 10 to 15 the number of battery manufacturers in Europe. This come along with end-of-life cars, with unused cars, with damaged cars, and also with some waste of the battery makers. So we have to bring, and this is the purpose of these associations, solutions to prevent and to offer to these, all this value chain some solutions in order to be able to bring back these metals to the cell industry. So it will serve a couple of informations. First, it will reduce CO2 again. If we make it roughly, it's another 20 to 30% reductions. Second, it will help the cost of the battery because obviously the car makers, the battery makers will be able to, I will say, to buy the nickel ones. If we can make it as simple as this, it will be obviously a bit more complex, but let's put it that way. And the second thing is that there is a step for the next step. So we are first to step in. We have already some solutions today, but there is nothing which is facing the massive industrial need of the market. We are all making the recycling at a level where today we have 1 million cars on the market, and most of the lithium battery are for only the tools. We are going to be able to manage a massive amount of product. So this will help to reduce the scope at using a scale industry. So this is where we are going to focus on today. Next slide. So to make a long story short, and I hope that it will not be, I will not hear the ring. So there is, first of all, is the motto, and for all of us around this table, is to say there will be no sustainable car without a sustainable battery. It's very clear. No clean car without a clean battery. This is clear motto. And today, we all know that the electrifications will help the CO2 reductions, especially in Western Europe, where we can have a lot of decarbonized energy. And these will have to come not at the expense of creating more damages than we can bring some solutions. So recycling will help this, but we also have to focus on something which is physical and which is feasible and which is meeting the market demand. The second thing is that there is still a gap to close. Today we are focusing on we have already on the market some recycled cobalt and recycled nickel. They are coming from route which could be already optimized, and we are working on it. Today, lithium is something on which there is still a lot of challenge. On Solvay, we have a unique solution there, and this is what we are going to plant in order to make it happen next year. So this is going to work out. And obviously, because there is going to be a sizable demand, there will be more and more innovation, and there will be more and more deliverables out of it. So this is why we say in Solvay, I mean, we are stepping in, but we are not going to stop here. And we really believe that we first have to allow the industry to set up, to create these value chains, and you will see that all the innovations that we bring will go further and will meet the demand. We have to be realistic in the deliverables. So to that essence, I think to make really this happen in a short time frame that we are going to face, as I mentioned, and multiply by 10 in 10 years is a massive demand. Each of us have to stay focused in the value chain. So we focus on the chemistry and purifications. Our partners like Veolia is focusing on the collect. We are going to set up some metals, which are going to be approved by the various cathode makers like Umicore, for instance, that we have today here. And at the end, to be back to the value chain. And our last partner is Renault, which is an OEM, which is going to give some kind of coherence to all these in order to be sure that we are all working together in order to collect the batteries from Europe, to recycle it in Europe, and to reinject it in the battery making of Europe. So one of our challenge today is I have seen some questions, is there is some competition. There is some competition inside Europe, which is clear, but there is also some competition outside Europe. And today, it's pretty clear that most of the refining industry and the recycling industry is situated in China. And China industry is looking after metals ores. So they take partnerships, obviously in some countries where there is some ores, finds, but they will look also after the ways that we will produce in Europe. So it's also up to us to build the regulation frame and the technical frame in order to be able to allow this recycling industry to emerge. So last slide will be the same slide than my friend just before. Thank you very much for your attention. I'm ready to answer to your questions.
Thank you, Christophe Quinault, of this comprehensive and systematic approach for the recycling and of the whole value chain of batteries. It's true that each of us need to bring our own knowledge and exchange it with the others in order to enable this transformation. I would like to start with the first question from the audience, and this will go for Claude Chanson. So how do you think that the battery regulation will fit to the low metal value batteries when we think about LFPs, or even further, maybe in future, like solid state batteries? So how would you reflect the current battery regulation and requirements for the future battery regulations in this regard?
Thanks, Marie, for the good question. Indeed, what we have to say is, for the moment, this is not clear. This is a really good question, because what we see in the batteries regulation is that the focus is on the critical materials. There are targets identified for nickel and cobalt and some others, but indeed, some others metal, iron and or low value metals or different chemistry are not addressed. And indeed, this is a concern. And we have to make sure when we discuss with the regulators and when we discuss particularly the secondary regulation about the recycling target, how they are calculated and so on, at least that the regulation do not impinge or reduce the capability to recover everything that can be recovered, even if we recognize that, of course, we understand the Commission priorities to underline the critical materials to be recovered and to set targets only on that one. That makes sense. But nevertheless, this set of targets should not indeed, let's say, yes, hinder the possibility to develop processes and recovery of other targets and higher recovery rates. So there is a little bit of incentive because there is also a global recovery rate, what is called recycling efficiency in the regulation, but that's not really a major driver. So our point today is to say, yes, it's potentially possible, but nothing is yet completely clear on this aspect.
Thank you. Maybe I would like to continue also with Christian Hagelucken. You come from the recycling company. So how do you see that your recycling company, which kind of incentives or support would be needed that such batteries that have very low metal value so would become part of your business?
So Umicore at the moment is really focusing on NMC and NCA type of batteries, so which contain cobalt and nickel. So far we are not active in LFP recycling, and I think Claude mentioned it already. The challenges for LFP are pretty high because the intrinsic value does not cover the recycling costs. So if LFP, but on the other side, of course, when we bring LFP on the market, it should be recycled as well. So probably when placing it on the market, there should be some mechanisms, also some financial mechanisms to pay for end-of-life recycling, because otherwise it will not take place. And this is maybe also a disadvantage of LFP, because the recyclability question is a bit open.
Indeed, yeah, it certainly comes with new battery chemistries, also new kind of challenges related to recycling. So I would like to next make a question to Christophe Quinault. So it's obvious that you work hands-on with the metals and metals production, and that the battery metals are needed increasingly, partnership is needed increasingly. Do you see criticality or lack of resources in respect to some of your raw material or supply chains?
So today, you mean in terms of metal sourcing, right?
Yeah.
So today, when we look at the metal sourcing, it's pretty difficult to have completely clear visions, as there is still some evolution in the battery need. So for instance, we used to have what we call the NMC battery, which are dominating most of the demand. So one nickel, one manganese, one cobalt. But because there was a high demand on cobalt, which is under controversy, as most of the cobalt is coming from Congo, so there is a unique supply chain, main unique supply chain. There has been the NMC has been enriched with nickel at the expenses of cobalt, and today we are talking about ratio where we have 8:1, so a very much a large number of nickel. So it creates temporarily some tension on the nickel value chain. Clearly, we do expect that there is a need for the mining industry to catch up and to bring some nickel there. So there is two aspects of the demand. There is not a real issue, I would say. There is not a real concern about the availability of the ores on the planet today. It's more a question of where are the refiners and where are the capabilities to refine these ores and to make it happen. And today, for all of these metals, most of the refining industry is located in China for 50% of it, and the other part are close to the mining countries. So this is where will be the limitations, I will say, is on the refining capabilities. So to be fair, this is why it enhances even more the need to bring some recycling opportunities to the market, definitely.
Marie, may I add a
Yes.
short thing on this? I think it fits well on the one side to the question about LFP and also to the statement in the beginning by Hans-Erik Merlin that batteries will last even longer and because they will have maybe second life and 20 to 30 years. The question from my side is a bit, is it really smart to have especially high cobalt containing batteries from the first or from the early generations and block them again in 10 years second life? Wouldn't it not be better to use LFP, for example, for stationary applications and try to recycle EV batteries at a certain stage when they cannot be used in EVs anymore?
That is
I think
actually,
we have to look at this whole second life question a bit more nuanced. It has a lot of question marks from my point.
Indeed, and it is also very much question of business models that now the ownership of the batteries are by the end user. But maybe the question is back to you, Christoph, that if you think of value chain, so do you see that there would be coming such business models where ownership is not so much by the end user, for example, that the materials would be managed in a different way also time-wise?
But today, yes, I mean, okay, I try to answer to the questions on time-wise, which is surprising your questions. Let's put it that way. In terms of on value chain on approach, it's pretty clear that there is going to be a need today. I mean, when we're talking about the recycling of the battery, most of the times we figure out that it will be only the end of life of the battery, which will be 10 to 20 years from now, right? So let's say no emergency. The reality is that there is already some EV vehicles today in the market. And when the battery makers are going to come, they will come with a lot of waste. And this waste will contain a lot of metals. And this is why with the recycling industry have to be set in the next, I would say, 5 years, up to 2025, 2036, in order to be ready to be able to support all this battery manufacturing in Europe, in order to allow also a regional and local value chain.
Yeah,
definitely. New battery makers, new car makers, new recyclers, and it will help to have all these metals keeping a circular economy inside Europe. This is pretty clear.
Definitely.
Yes.
Maybe I will go. I have one question from the audience for Claudia and so on. So it's more general. So how do you see that Europe is situated when we compare the recycling in USA, Japan, China? Is Europe a leader? Are we behind? Would you situate Europe in average?
Well, that's indeed a very broad question. There are different aspects and strong and weak points for all of the continents. Clearly, I would say the facts show that China is leading when it's come to the battery industry. And this is also associated with the recycling industry. As you may understand, a lot of primary scrap coming directly from the manufacturing is available in China, and that's not the case in other countries. And so we have seen that not only the battery manufacturers, but also the recyclers have developed in China. That's where we start from. Now we see a lot of good initiative in US, for example. We have startups which are now starting recycling lithium batteries in the US. I would not say this is yet a strong industry, but we see a significant trend, which is, I would say, based on the competitiveness, which is indeed business models. And then we have Europe, where we have a different case. We have, first of all, a long history of battery recycling, probably more than other continents, because we had the batteries directive in 2006, and we have started recycling other technologies in larger scale before we had the lithium batteries industry coming up. So that's where we start from. And now we will have indeed to compete, as I said in my presentation, with the tools we have. The tools we have is probably we have the best regulation when it comes to environmental protection, sustainability, and so on. And in fact, if we want to compete, we have to use these tools as a competitiveness criteria. And that's where we support indeed this batteries regulation as setting up the rules to support that. And of course, we have also this volunteer approach of circular economy, which may help, having based on the European market, which is, as you know, for EVs very significant, and probably the second market after China. So we will have the material, and the recycler will be capable of doing the recycling here. But it's still depending on the conditions we discussed, whether we will have indeed the level playing field, which is applicable and applied, which is avoiding export, to cheaper countries, which would not respect the same standards. That's one point, to keep the circular economy in Europe. And then if we keep it in Europe, of course, we also have to make the recyclers competitive, which means that the target of becoming more sustainable or having a sustainability ambition should not completely hinder or, let's say, kill the competitiveness of the industry by, let's say, too ambitious targets, as I said. So for Europe, still a lot of conditions to be fulfilled.
Yeah, and maybe we should think of this sustainability that to be able to brand but build it also in such a good way that it can truly become competitive edge instead of burden, but really
Indeed.
By different, whether it's innovations but also business models, also setting up standards like mentioned. So to try to do everything that we could use it as a benefit of. And I think the whole globe is still interested of keeping the globe in good shape. So it should be everybody's target as such. I have still couple of questions from the audience about the battery passport. So should these passports need to be in EVs only, or are they valid for any kind of batteries in future? How would you comment, Christian?
Yeah, I would say we should start with a passport for EVs because there's the biggest need, and there also are the biggest transparency challenges, especially at end of life. I mean, think about the fate of our current cars, what is happening with them at end of life. In many cases we don't know, and then we know many of them are exported. So really have to avoid that the same fate is happening to EV cars and the batteries. Of course, if an EV battery is transferred into a second life into a stationary battery, then this should be covered by the passport as well, because the passport has to follow the life of the battery, the whole life cycle. And from my point of view, maybe at a later stage, of course, we could also develop passports for stationary batteries, but we shouldn't try to do too much at the same time, because then it might become too difficult. So let's start where the highest priority is, and for me the highest priority is on EV batteries.
And one more question related to that. So what do you think about the state of health? Should that be addressed in the battery passport somehow?
Yes, I mean, this state of health I mentioned as one example of dynamic data. So of course, when you place a the battery on the market, the state of health is clear. This is the state of health of a new battery, but interesting, of course, is the state of health after a couple of years, especially when you consider going for a second life or not. Yes, these kind of data should be there, and usually they are in the battery management system. The big question is who has access to the data, and what is important, because also, of course, it can be proprietary data and so on. So we have to well define who has access, and stakeholders who claim to have access. They need to be authorized, certified. So only if they are follow certain standards, if they're certified, then they can have access to data. And by the way, the same is valid for a dismantling manual or all kind of information with regard to the parcel. We should avoid that everybody simply can get access, because this would then be counterproductive to a level playing field. Then you would find again all kind of shady players in the game.
Thank you, Christian. And then one more question to Christoph about partnerships. So how would you see the importance of partnerships if we think inside Europe or globally? Like, on the other hand, we are talking here about European competitiveness, but it has been, we have heard now many times that we have very strong global players and raw material. We are dependent on raw materials, and recycling technologies are well developed also outside of Europe. So how would you see that partnerships inside Europe and globally, how is the importance, or how would you comment that?
Yes, absolutely. It's a very good question, actually, and we are always also focusing on the fact that we come from a global economy, which is a bit more regional, but with still some global vision. So, and this is exactly what is going to apply for the circular economy related to battery. We will try to have the flows which will remain at the regional level. When we say regional, is Europe or some region in Europe, it will be the same, some in China and some in the US. But the technology is global, and the people which are going to bring the technology and the partnerships that you can provide can come from various fields. Especially, it can be financials, it can be the regulation expertise, and it can be also the technology. And this is typically a global vision that we are going to bring. So if you take the example, sorry, I will use the example we are dealing with, but Renault is today going to set a partnership with a company which is coming from Japan and China, which is Envision. It's a battery maker. And we are today in discussion with them, obviously, in order to bring something which is going to help them to consider on how to manage the waste. Is it going to be a recycling solution inside Europe? And these are truly the questions that they're asking themselves today. And it's the same for any kind of battery maker. So they will come with their own expertise from Asia, their own demand, their own expectations, and we will come with our own fit. So it's still, I will say, a global technology approach, which will give the fit, but the purpose of the value chain and the purpose of the business scales will remain regional if we want to keep it as profitable as possible. We have to keep in mind that it has to be a circular economy. So I mentioned Claude Chanson. I mean, if it is going to cost to everybody, there will be no sustainable case. It has to be a case where the various chain will be able to generate some profit at the end of the day in order to be able to make it sustainable.
Thank you, Christoph. I think now it's really time to thank our awesome gentlemen of your great vision and speeches. I think I would carry away a couple of things from today. So working together in the circular value chain is a critical. Working together, whether it's research or industry, data sharing, realistic innovations, being realistic with the situation, starting from that so we can have a true impact on battery raw materials, recycling, traceability, and sustainability. And with these words, I would like to close this session and thank you everybody for joining us. And you can continue in the next sessions of long-term research for batteries, what are the next priorities, or research and innovation worldwide, what is ongoing. Thank you.
Thank you very much.
Thank you very much.
Bye, everybody.